Hello, good evening, everybody. How are all of you today? Okay, so I hope that you all are doing very fine. So, okay, okay. Can you all see or not? Can you all see or not? Can you all see properly or not? Can you all see properly? Yes. Okay. So I'm going to test a little screen because I'm not too sure. If you let's say can hear or not? Can hear or not? So I'm about to go to presentation modes. So if let's say wait, wait, I think uh, sorry. Okay, so I hope that you all will be able to gain something from it. And then if you look carefully inside my description profile, I've actually shared some files, including the mind maps and then including the tables and everything. So I hope that it will be able to helps you a little bit, lah, okay. So if let's say if it is really going well, hmm, yeah lah. Okay, yeah, can okay, wait a second. One more. Okay, because I'm not very good with these StreamYard things. But, okay, display setting. Okay, duplicate, extend the display. Okay, okay, changes. Okay, okay, so okay, there we go. Okay, so I'm about to go to this one. Wait, okay, are you ready? So with the administration, let's begin, shall we? Okay, okay. Okay, so can you all see or not? Can I all see or not in here? Okay, so I'm on this presentation mode right now. So if you cannot see, then let me know. Okay, okay. So with that annexation, shall we begin? You can already download the answer from the link. I attach a link. Do you see that? So the link you can download there, and then I also put it in some of the groups in Telegrams. You can also get it from there. And if your teacher is from, I post in some teachers group. If the teachers are able to share with you, then okay lah. But if cannot, then never mind. Later you can also private message me and text it from me. Okay. Okay. So shall we begin? Okay, so welcome to my answering technique for STPM Chemistry Semester 3. As I promise you all that every semester I will try my best to do one answering technique for every semester. And if you have been following me since semester 1 to semester 2, so I hope that it will be able to help you to understand better for semester 3 also. So yeah, okay. Okay, so with that session, shall we begin? Okay, afternoon. Okay, so a little bit about my profile. I'm Mr. Chu. Uh, is it moving or not? Is it moving or not? Is the screen moving or not? Because I'm now showing about me. Is it showing about me? Wait, send, share screen, window, technique, Java. Okay, is it sharing screen or not? Because I'm quite worried. Okay. Do you see the screen moving or not? Uh, Wait a second, because I'm not 100% sure what is going on. Uh, okay, so now, okay, so this is me. Oh, okay, okay, okay. So I'm showing you this. You should see this. Okay, wait. Wait. Screen. Then share screen. Entire screen two. Okay. Okay. Okay, can. Okay, better already. Okay. Yeah, so this is a little bit about me. So 42 years old, and then teaching currently in Tasik Utara, Johor Bahru. This is my 20th years of teaching. Uh, so I've been teaching since 2003 until 2023. So hopefully with this 20 years experience, I'll be able to uh, helps you all to understand better of how to answer for semester 3. Okay. Okay. So shall we continue? Okay, so this is a little bit of my achievements. I'm a national trainer for STPM Chemistry New Syllabus from 2012 to 2017. I quit all of this because I have involvement in other things. As I already told you, since semester 1 and semester 2, I'm more involved to sports right now. So that's why. Okay, so I'm also a national trainer, okay, national moderator, motivator, and lecturer, giving some talks about STPM chemistry. I also write some books. So you already know me, lah. So all these are you know me, lah. Okay, scheme of assessment. So you have already go through 2 semester, and this is your 3rd semester. You have finished. Ulangan 1 and Ulangan 2 already. So shouldn't be much of problems to all of you lah. Okay. Okay. So this is the experiment, and then I believe that your school teacher will ask you all to check about the marks already. So probably no problem. So we have already given you 18, 19 marks for paper 4 already. So the remaining marks is up to your hands already. Okay. Okay. So can I? Okay, so I'm moving on. So okay, before examination, as usual, you make sure you have read in details all the chapter. If possible, make your own short notes. I've also already shared a lot of short notes already. Mind map is a must, definitely for organic chemistry. A mind map is a must, and then you should also do a lot of questions. Organic chemistry is all about questions. You have to do a lot of exercises. Okay. Okay, and then you'll do all the passive questions. Actually, from the 2022 Sem 2 Ulangan, you can see that I started to see some of the trend of questions of repeating. What do I mean trends of repeating questions? In 2022 Sem 2 Ulangan, they got one questions which repeat entirely the same with 2013 Sem 2 Ulangan. Okay, so that's why I said that there is a benefits if you do the past year questions, because there are trends of showing repetitions of these past year questions already. Yeah. So you must try your best to do all the past year questions. Okay. Okay, so I also share with your teachers already on the questions and also answer and everything. So I share everything's possible. So if you have any problems, you can probably ask from your teachers there. Okay, and then do a study groups. Okay, a study group actually helps you to understand between one another. Because I feel that students nowadays, they don't really ask questions to teachers really. So they ask their friends better. So it's better for you to discuss among your friends. Okay. Okay, so with that, that is more or less the tips. Okay, okay. Then let's go to the answering for STPM Chemistry Semester 3 already. So I've already set to you a set of question papers already. Though there are little problems here and there. I'm so sorry. While you are doing your questions, that you might face, hey, is there got answer or not? Because some of the objective questions, there are little mistakes when I first set in. So never mind. So I just shows you the technique of how to answer. So though you might not get the answer because the answer is wrong, but this won't happen in STPM. This will only happens in my Mr. Chu's examination questions. Okay, sorry for that. Okay. Okay, so good afternoon, everybody. Okay, thanks for coming in. Okay, so with that session, let's go to the question, shall we? Okay, so let's have a look at the question number 1. So, by the way, wait. Okay, so based on the time given, you have 90 minutes. So you should spend only 20 minutes for section A, 20 minutes for section B, and 50 minutes for section C. So in another word, you must try your best to solve your objective question as fast as you can. Okay, so like one question, like 1 minute plus, 1 minute, 20 seconds, 30 seconds, like that. Okay. So let's have a look at the question. So jasmine is extracted from pyrithium flower, is used as the insecticide. So this is the structure of the jasmine. How many carbon atom undergo sp2 or sp3 hybridization in the jasmine molecule? So I'm going to show you which one is sp2. So sp2, I use a red color. So you have 1. This is also sp2, 3, 4, and 5. So these 5 are sp2 hybrid. Okay, and then you also have 6, and then 7, and also 8. So there are a total of 8 carbons which undergoes sp2 hybridizations. Okay, so okay, then good afternoon, everybody. Okay, then for sp3, I will label it using this purple color. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are a total of 13 carbon which undergoes sp3 hybridization. So this will make your answer to become C. Okay, so that is how you are going to solve for question number 1. Okay, so hopefully you all can understand on how to read sp2 and sp3. The key of reading sp2 or sp3, number 1, you have to read the number of the surrounding atom. So if there are 4 surround atoms, usually they are sp3. If there are 3 surround atoms, probably sp2. If there are 2 surround atoms, probably sp. For carbon, this is definitely true for carbon. Okay. By the way, lone pair electron and single electron is also considered as hybridized electrons. So sometimes you see lone pair electron. So even if it is lone pair electron, you must also consider it as a sp3 hybrid. What does I mean in here? That means that if you have like this, the option. So let's say you have a C, okay, with a lone pair electron. Then this one is a H. This one is a H. Then this one is a H, let's say. This is also considered as a sp3. This is also sp3. Okay, and even if you have a single electron, such as like this, okay, no matter a single electron or lone pair electron, they are both the same. They are both sp3 hybridization. Okay, so let's move on to the next slide. Okay, so that is for number 1. So immediately we go to number 2. Typical compounds. A typical compound used to make harder outer layer of golf ball has the following structure. So this is the structure. Which statement is true about the molecule? How about O bonded to C? Because the question does not ask about this one. The question does not ask about O, so usually I'm not going to share O. But if you want to look back at the O here, in the case of O, we are not going to discuss this. Okay, if O, you have to know by yourself that there are 2 lone pair electrons in here. Okay, so this one is sp3. Okay. Some of you have question. How about the O in C? So in the O in C, then I can only show you the one which is bonded inside the ester there. So this is sp3. Okay. Okay. So there are total of uh, there are total of 8 carbon, not 5. I already highlighted. So if you're afraid of this one, you might want to screenshot and save on your own. Okay. Yeah. Can I move on to the next one? Time constraint. So I must move very fast. Okay. So number 2, a type of compound used for harder outer ball. So which statement is true about this molecule? Number 1, it shows cis-trans isomerism. So does it show geometrical isomerism? No, it does not show, because in order to exhibit geometrical isomerism, you have the same molecule in here. So when you have the same molecule, that means that it's the same atom or molecule. That means it does not exhibit geometrical isomerism. So A is wrong. And then B, it rotate plane polarized light. It also does not has a chiral carbon atom, so that is why it does not rotate plane polarized light. Okay, and if you look carefully, it has the molecular formula of C5H8O2. Okay, C5H8O2. Okay, so C is also wrong, and it can exhibit various structural isomer lah, because one of the structural isomer is carboxylic acid, isn't it? Okay, so this is how you mentions in here lah. Okay, okay, so that is how you are going to answer for number 2. So number 2, the answer is D. Okay, so any questions you can just key in inside the comment. I'll try my best to answer you all. Okay, then number 3, in a complete combustion of 1.027, there is a little bit changes. Even if there is changes, also this is wrong. So I'm just going to show you how you are going to solve it. Sorry for that. Okay, so in a complete combustion of 1.027 of hydrocarbon X, so 1.43 gram, 459 gram of water and 3.171 gram of carbon dioxide are produced. What is the relative molecular mass of the X? So in here, whenever you see such questions, you must use the mass-to-mass concept. So mass-to-mass concept means, let's say, what do I mean by mass concept? Because in here, we say that one carbon produces one carbon dioxide. Okay. So that means 12 gram of carbon in terms of RAM. So we say that 12 gram of carbon produces 44 gram of the 44 gram of carbon dioxide. And then therefore, if you have, let's say, 44 gram is the mole of the carbon dioxide is 3.17. So what is your X? So what is your X gram of the carbon? So you use this method to calculate. You use the ratio methods to calculate the mass of the carbon. So you get 0.8648. And then for hydrogen, we said that 2 hydrogen will produce 1 water. Okay, 2 hydrogen produces 1 water. So therefore, 2 gram of hydrogen produce 2 gram. Is 2 gram. 2 gram of hydrogen produces 18 gram of the water. Okay, so therefore, if you have the mass of water is 1.459. So what is your mass of the this one? So y is equals to what? So you also use the ratio method. So in the end, you get your y is equals to 1.622 gram. So once you get the mass of carbon and hydrogen respectively, you can eventually learn how to use back the calculation of the mole method. So you get eventually you get your ratio is 1 to 2.225. So 2.25 is actually 9/4. So it's the ratio is 4/4 to 9/4. Therefore, empirical formula is C4H9. So since molecular mass of the empirical formula is 4 times 12 plus 9 times 1, you get 58. So therefore, the possible molecular mass is 116. But inside there got no answer. So therefore, your correct mass is 116. So that is why in ABCD here you don't have answer, and I apologize for that mistakes. Okay. Okay. So hopefully you can at least know the, how to get to the answer is I'm more concerned about this. Okay. Yeah. I know. I'm sorry for that. Fly with C. Okay. I know the data given is different from the download. Okay. Sorry for that. Though if the answer, the latest one that I share, I already sent the corrected one already. So I apologize for that. Okay. Okay. So shall we continue? So this is number 3. Okay. Okay. Then we go for number 4. Okay. So when a mixture of 2-methyl propane and chlorine exposed to sunlight, chlorination occur. Which statement is true to regarding chlorination of 2-methyl propane? Okay, so the initiation steps involve the breaking of CH. No, the initial steps involve the breaking of ClCl bond, which is the initiation. And then the mechanism involve a free radical addition. It's not free radical addition, it is free radical substitution. Okay, so it's wrong. This is wrong. I typing error. This is wrong. This is wrong. Aduh, Mr. Chu sudah blur already. This is false. Okay. And then for C, the reaction does not require any catalyst. If they say one catalyst, the only catalyst in here is UV, ultraviolet light. Okay. Instead of using FeCl3, it is ultraviolet. And then in here, the major haloalkane product is 2-chloro, 2-methyl propane. So D is also false. So I'm so sorry. There are no answer inside here. I'm so sorry. In question, I give substitution. Okay. Then I think I corrected it already. Substitution. Okay. Sorry for that. Can I say that this question, objective question? Nothing. I apologize for all the mistakes. Okay, so it is a substitution. So B is correct. So the answer in here is B. Okay, substitution. I already corrected it in the questions, I guess. Okay, so it's substitution. Okay, so for more information of how the mechanism of the free radical substitution reaction, so you can always go to my YouTube to download for more details. Okay, later also at the end of the day, later also give you a link so that you can eventually see from the short notes that I given to students, I share with students on how to this one. Please make sure that you come back to this YouTube, and then below the description down there, I will attach another link that gives you the short notes for semester 3. I try my best to help you as much as I can. Okay. So that is for this one. Okay. Then we go to number 5. Put one in, react with hydrogen chloride to form 2 isomer. The following statement describe the reaction except. Okay, so chloronium is formed as the intermediate. Okay, so this is the mechanism for the hydrohalogenations of the alkene to the hydrogen halide. So if you have put one in, not put 2 in, I typing error. This is put 1 in. This is put 1 in, not put 2 in. Sorry for that. Okay, so for put 1 in, so you start from the attack of the pi electrons to the partial positive charge hydrogen, and then you undergo heterolytic fissions in here to form the secondary carbocation, which is more stable, while primary carbocation, which is less stable. So in here, your intermediate in here is a carbocation. Okay. So and eventually, after the reaction happens, so the bromide ions will attach to this hydrogen, and you form 2 bromobutane as the major product, while 1 bromobutane as the minor product in here. Okay, so from this one, chloronium ion is formed as the intermediate, which is wrong because we form carbocation. The major product is 2-chlorobutane, which is correct because the major product is indeed this one. The reaction is an electrophilic addition reaction, which is correct. And then the reaction involves the breaking of the pi bond. So the pi bond becomes sigma bond. Okay, so it does breaks to become the sigma bond. Okay. So with that, the best answer in here will be A. Okay. Teacher, what is a chloronium ion? Chloronium ion looks like this. Chloronium ion looks like this. This is C. You only have this chloronium ion when you have this chlorine in the when halogenation of the alkene. Okay, so this is what we call as the chloronium ion. Okay, so chloronium is referred to this. Okay, okay, so that is how the intermediate. So this intermediate is formed when halogenations of the alkene take place. Halogenation of the alkene take place. Okay. Okay. So that is for number 5. Okay. So far, any questions for number 1 until number 5? Okay. Hopefully, no problem. Okay. Then immediately it goes to number 6. Okay, so which following aromatic compound undergoes nitration in the substitution of the NO2 group at the meta position? So in order to understand what is the position that we go, you have to first understand what is the groups brought out by all these material, all these substance. So in this case, CH3 is a para director, and then OH is an auto para director, NO2 is a meta director, while NH2 is an auto para director. Okay. Okay. Wait, I see some questions in here. Teacher, can you explain primary, secondary carbocation? I'm so sorry because it's going to take a very long time. Okay, we hold on to this question. If let's say got behind later got time, then I will come back to this. Okay, so okay, so but actually these are considered basic. These are considered basic of what is a carbocation thing. So try your best to you go and search on my YouTube to find out more. Okay. Okay, so back to the question, shall we? Okay, so back to the question. So from here, if you want to nitration at the meta position, so the best answer in here will be C. Okay, C. Okay, then number 7. So the reaction scheme for the synthesis of ethanoate from bromoethane is shown, bromomethane is shown in the following scheme. So this is the scheme. So what are the appropriate reagent and condition for reaction 1 and 2? So in here, if you want to change haloalkane to become cyanide, so you use ethanolic potassium cyanide, under reflux, and then followed by acidic hydrolysis, to form the CH3COOH. Okay, so in here they use dilute sulfuric acid. As long as it is any dilute acid, so it will give this carboxylic acid as your product. Okay, so the best answer in here is C. Okay. Okay, so that is how you are going to solve for question number 7. Okay, Ken? Okay, so hopefully not much of a problem so far. Okay, so if not much of a problem, then we goes to question number 8, shall we? Can? If I'm going too fast, you can always slow me down. Okay. Okay. Then number 8, hydroxy compound W fulfill the following requirement. Okay, let's play elimination games. Okay, can we use hydrogen H3O plus? Sorry. Okay, teacher, can we use H3O plus during writing equation? Then you see, inside my solution here, I use H3O plus. And then so you can use in okay, in structure assay it depends. If it is structure assay, if the question specifically uses dilute hydrochloric acid, then you must use HCl. But if they just generally said acidic hydrolysis, basically you can use H3O plus, no problem. Okay. Okay, then the next one is concentrated sulfuric acid still with dilute or not. Concentrated is concentrated, dilute is dilute. So it's totally two different things. So don't mix up. Okay, it's totally. And if there is a places that you require to use concentrated sulfuric acid, then you must stress that it is a concentrated sulfuric acid. Okay? Okay. Yeah. Okay, so number 8. Hydroxy compound W fulfills the following requirement. Okay, number one, produce 1 mole of hydrogen chloride after reacting with phosphorus pentachloride. Okay, so as you can see in here, you want to react with you want to form 1 mole of hydrogen chloride after reacting this one. So there must only be 1 alkyl alcohol. Now you listen carefully to the explanation. Okay, teacher, can we do not put the word reflux? You can represent reflux with triangle. Actually, the reflux because Mr. Chu lazy to draw the triangle lah. So that's why I use the word reflux. Okay. Okay, back to this one question. Okay, so now this PCl5 can only react with alkyl alcohol. That means phenol cannot. So in here, B is wrong and then D also wrong. Okay, B wrong, D also wrong. Because B, it is, if you notice carefully, so this one is alkyl alcohol, this one is alkyl alcohol. So you form 2 mole of HCl. And then this one also 2OH, you also form 2 mole of HCl. So B and D is already out from our choice already. Okay, so our remaining answer is either A or C. So let's continue with the second statement. Produce 1 mole of hydrogen group. So it must have 2 OH group. So in here, it doesn't really matter if it is alkyl alcohol or phenol. As long as you have 2 OH group, then it will fulfill the requirement already. And as you can see in here, so there are 2 OA in A, but there are only 1 OH in B. Okay, what does it mean by 2 OH group in here? Because when you react ROH with NaOH, ROH with Na, because I use mouse to draw, so I'll take a little time. You form RONA plus half hydrogen. Okay, plus half hydrogen. Okay. So if you want to have 1 mole of hydrogen, then you must have 2 H. So A is correct, B is wrong. Teacher, heat and reflux same. Yes, heat and reflux to reflux you require heating, so they are the same. Okay, and finally, it gives a yellow precipitate because it has a methyl alcohol group. So our final correct answer in here is A. Okay, so that is how you are going to answer for number 8. Number 8. Okay, Ken? Teacher, what is the difference between heat and reflux? Heat and reflux, same. Because to reflux, you require heat. So just put inside your equation, just put triangle. No matter it is heat or reflux, same thing. Okay. So hopefully you'll be able to catch it somehow until now. Then we go to number 9. 2 types of female sex hormone are estrone and estradiol. So this is the structure. Which of the following can be used to differentiate between the hormone? Okay. So number 1, bromine at water at room temperature. Okay. So both can react because both has a phenol group. Okay. Both can react because both has a phenol group. Some of you started to ask, teacher, if H2OH plus is acceptable. Yes. H2OH plus, H2OH plus, H2O plus, they are all acceptable. Yes. Okay. Just draw. Teacher, if they ask the condition, how just draw the triangle? If equation, just put triangle lah. If statement, then you just put heat law. If you worry about the word, teacher when to put heat, when to put reflux. Actually, we are not really stressing about heat or reflux. Because to reflux, you require heat. Then just put heat. Heating, okay already. Okay, don't worry about it. Okay, back to the question. So bromine water at room temperature. So both estrone and estradiol does react with the phenol, so cannot use to distinguish. So A cannot. Okay, so for B, phosphorus pentachloride. So phosphorus pentachloride can be used to distinguish between estrone and estradiol, because estrone does not have alkyl alcohol, while estradiol have alkyl alcohol. So B can. If why? Okay. And then C, Fehling reagent. So Fehling reagent does not work on both of them because both does not have aldehyde functioning group. Okay, and then finally D, iodine in aqueous solution. Both cannot because both does not have COCH3 lah, methyl alcohol or methyl carbonyl lah. Okay, so the best answer in here is B. Okay. Okay. Teacher, positive iodoform test produce yellow or orange? Yellow. Later there is a question in relates to it, so don't worry about that. We'll come back to this. Don't worry. Okay. Okay. Shall we continue? Okay. Then we goes to number 10. A chemical reaction between Grignard reagent and organic compounds P yield the following products. So this is the product. So this product is then hydrolyzed to produce organic compound Q, which is the following match of P and Q. So in here, after the hydrolysis, so after the hydrolysis, you just substitute MgBr to become H. So this is the product of your hydrolysis. You become a secondary alcohol. Now, if you look carefully, this is a secondary alcohol. Now, if you have a secondary alcohol, you must always bear in mind to form a secondary alcohol, you can only react Grignard reagent with aldehyde other than methanol. Because if Grignard reagent react with methanol, Grignard reagent react with methanol, then you form primary alcohol. Grignard reagent react with aldehyde other than methanol, then you form secondary alcohol. And then to form tertiary alcohol, you react with ketone. So from here, you can already see the moment that your Grignard reagent has a ketone, which is wrong. Okay, ethanol aldehyde may be correct, ketone is also wrong. So A and C automatically wrong already. So let's have a look at B and D as our question. So from the structure of B and D, so this is the primary alcohol, and then this is the secondary alcohol that we are talking about. So this question, they purposely put it in such a wrong way that they were hoping that it will confuse you all. But actually, this one and this one, they are actually the same thing. Okay, so the aldehyde used in this case is propanol. Okay, so the best answer in here is D. Hey, I'm discussing this question while you all talk about 2,4-dimethyl phenylhydrazine. Later, we have for that later. I'll show you the technique of how to write the reaction later. Please be patient. Okay. I know most of you are very ready for semester 3 and I'm glad that it happens. Okay, never mind. So any questions from number 6 until number 10? Any questions for number 6 until number 10? Okay, so hopefully no problem. Okay, so if there's no problem, shall we move to question number 11? Yeah, so let's go to question number 11, shall we? Okay, question number 11. Which sequence shows the acidity of ethanoic acid, chloroethanoic acid, and phenol in decreasing order of this one? So you have to know chlorine in the CH2COH is the act as an electron withdrawing group, or we say inductive effect. So when you have inductive effect, it will increase the acidity. Whereas ethanoic acid is more acidic than phenol due to the strong C11O withdrawing group. Okay, so therefore, in terms of, now look carefully, the questions one what order? The questions one decreasing order. Okay, the questions one decreasing order. So if it is decreasing order, so you arrange from the strongest to the weakest. So the strongest is CH2ClCOH, CH3COH, and then followed by C6H5OH in here. Okay. Okay, so that is for number 11. Okay. Okay, then we goes to okay, can understand so far? Yeah, so if no problem, then we goes to question number 12. Okay, the compound reacted, the compound below react with excess ethanoyl chloride. This structural formula of the product is formed. So you are reacting with ethanoyl chloride, CH3COCl. So CH3COCl can react with what? CH3COCl can react with alcohol, can react with hydroxyl group. I said hydroxyl group generally. No matter it is a phenol or it is alkyl alcohol, both can react. Okay, so it reacts to form this what? Ester, and then it can react with NH2 to form amide also. Okay, so both can react. So at the end, so both NH2 and OH in this compound can react. So as a product, what is the product in form? It form product C. Okay, it form product C. Okay. Okay, so that is how you are going to explain for the formations of the compound form. So both NH2 and OH form, because in this question they say excess. So when they say excess, that means as long as you have excess, then you can both this OH and also NH2 can react lah. Okay. Okay, so that is how you are going to answer for number 12. Okay. Okay. So number 13. So number 13 is deducing questions. So let's have a look at the one by one. When a mixture of NaNO2 and CoHCl added to the compound solution P, solution Q is formed. When phenol is added to Q, or an orange precipitate is formed. Which statement is true regarding to P? Okay, so when you react P with NaNO2 with HCl, how do I say solution? Okay, when you react NaNO2 with HCl, so you form Q lah, okay, and then Q react with phenol to form orange precipitate. So this orange precipitate, you must know by yourself, it's not 2,4-dinitrophenylhydrazine like your all story just now. Orange precipitate in here is actually the azodine. This one is very, very clear. Okay, so now the moment that you always see this NaNO2 in HCl, the moment that you always see NaNO2 in HCl, this is a reaction to shows the presence of NH2. This is a reaction to shows the formation of the NH2, be it amide, be it alkylamine, be it aniline. All of them, as long as you have NH2, you can react with the NaNO2 in HCl. Understand? Okay. Okay. So P is more basic than aniline. Okay. So P is actually less basic. P is aniline. You must know by yourself that P is aniline. So automatically you must know that P is aniline, as it can form azodine, which is the yellow precipitate. So P is less basic than ethylamine due to the induction effect. Okay, so A is false. And then due to the large benzene group, so P is very, very insoluble in water. So B is also wrong. Okay, but P is soluble in HCl. However, P is soluble in HCl, yes, okay, because it is basic, so it can dissolve in HCl. Okay, P can decolorize bromine water, which is correct, to form a white precipitate of 2,4,6-tribromoaniline. Okay, and then number D, P is not phenols because it does not form a violet complex color. Okay, Azri Azam, this one is not this one this is not SPK SPL. Okay, never mind. Memang KTE SAS kena bagi tahu, kena ambil attendance Okay, tak apalah. Jangan risau ni bukan paksaan Kalau cikgu kamu paksa juga, tak apa, bila-bila saja boleh tengok balik YouTube nanti. Okay, good luck Okay, so whatever it is. So why azodine means aniline? Only aniline can form azodine. The rest cannot. Okay, only aniline can form azodine. Okay. For more information, read back at the aniline structure. Or later, if we have extra time, then I'll show you. Okay. Okay. So number 13 is C. Number 13 is C. What is the What is the violet complex refer to? Violet complex is referred to the this one. Violet complex is referring to the FeCl3 Fe this one. This is a chemical test. This is a chemical test for phenol. So it is for this one. So it is a chemical test for phenol. Okay. So that's why I said only phenol. Okay. Sir, should we test positive, negative, inductive effect? Because the question said, generally, when we say inductive effect, it is negative. In organic, most of the time when we say inductive effect, is usually negative. How to put in words? If you see a lot of international books, they say inductive. When they say inductive effect, it's definitely a negative inductive. They seldom use the word positive inductive effect. They seldom. When I go through this, I used to last time have this about this positive negative inductive effect. But as I go through these books, they usually, when they say inductive, is usually negative. Withdrawing. Inductive is withdrawing. Okay, inductive is withdrawing. Okay. Yeah, so that is for number 13. Okay, so number 14, amino-ethanoic acid can react with the rest of the following reagent except for sodium hydroxide. So in here, you must know by yourself, amino-ethanoic acid cannot react with ethanolic KCN. Ethanol with concentrated this one. But actually, yes. Actually, there is no answer in here. There is no answer in these questions. There's no answer in these questions because amino acid can react with all of them. Can I put in this one? Sorry, can you give me like 1 minute? Can you give me like 1 minute? I show you this one. I supposedly shows you about this thing. Now, what can the amino acid react with? So because amino acid has both alcohol group and also aniline group, so anything that it has this alcohol group and this one, they can all react with it. A little bit smaller. Sorry for all inconvenience caused. Okay, so back to this one again. Okay. Okay, so in here, these are due to the amino group, it can react with HCl, it can react with acyl chloride, it can react with the nitrous acid, okay, and due to the carboxyl group, it can react with metal hydroxide or metal carbonate, it can react with alcohol catalyzed by concentrated H2SO4, and it also can react with the LiAlH4 reduction. It can also react with PCl5 to form the acyl chloride, and then it also can react with concentrated ammonia to form amide. Okay, so in these selections, A, B, C, D, all of them can react. So that is why there is no answer for this. Okay. Okay. So, teacher, when writing equation, do we need to write H? No need. The most important, if you look at the way of how I write the equation in here, you look at the way of how I write the equation in here. This is the way of how you write your LiAlH4 in here. This is the only way that this is the only way for you how to write your reduction equation. Okay, if you use LiAlH4. Okay, so don't put bracket H. Okay. Okay, can Okay, so that is for number 14. Okay, can we go on to the next one? Okay, So the following polymer shows a polymer which made up from two monomer. Which of the following can be used to prepare the polymer above? So in here, the monomer should be carboxylic acid and alcohol. So the carboxylic acid is 1,4-benzene dicarboxylic acid, and then alcohol is propane 1,2 ethane, not propane, typo, ethane 1,2-diol, ethane, propane, sorry, propane 1,2-diol, 1,3-diol, 1,3, not 1,2, 1,3, yeah. Typing error in here is 1,3, yeah. Propane 1,3-diol. Okay, so the best answer in here is A lah. Okay. It's C, 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 C. Sorry, C, 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 C. Mr. Chew teruk betul. C ya, C ya. Answer is C. Pardon me for that. Okay. Sorry. Mr. Chu also. Sometimes Mr. Chu also made this kind of mistake. Okay. So hopefully you all can understand. Okay. So with that, that is all for the 15 objective questions. Okay. So any questions for objective 11 to 15? So if you want to get back all the tables in here and there later, you can always revisit this YouTube later and go specifically to the questions that you want. Okay. Okay, so that is for objective. So any questions so far? If no, then we're going to continue with the structure questions. Okay. So since objective, most of you have no problem, then we are going to go for section B, which is the structure questions. So you are usually advised to spend 15 to 20 minutes on this section. So that means one question 10 minutes. One question 10 minutes. Okay. So answer should be short and clear and do not focus in one question. Structure questions, if you know, then you know. You don't know, no matter how you think also, you will never know. Okay, so my advice for structure is one question, maximum 10 minutes. Okay, don't go more than that. Okay, so and for structure questions, I set a little bit. 16 is easy, 17 not easy. Okay, so and then nowadays I notice a trend that they love to give complicated structure lah. So I purposely inside this question put a rather complicated structure because I want to students to get use of drawing the structure very fast. Okay, drawing the structure very fast. Okay, so you must get used to draw the structure fast in order for you to rush your time. Okay, so shall we go to the questions with that session? Okay, so question number 16 sounds like this. Methyl cyclohexane, and methylbenzenes react differently with bromine under different conditions. So complete the table below by writing the type of the reactions and the conditions required and the major products in here. Okay, A, reaction of methyl cyclohexane with bromine. So what is the type of reactions in here? So must have free radical substitution. Without the word reaction, okay. The keyword must have free radical substitution. Okay, free radical substitution. Okay, and the condition is UV or HV lah. Actually UV or HV, or you write ultraviolet also can, no problem. Okay, ultraviolet also can, no problem. Okay, now because the question is only one major product, so the product will attack only at this one. Now you must know by yourself very clearly here. Inside here you can only have one more carbon. Can you give me like 2 minutes? Sorry, I'm going to keep my clothes. Sorry, ah. 落雨好收心啊 Okay, so now is it okay that we didn't write the reaction? Yes, it is okay if you don't write the. Sorry, okay, so is it okay if we didn't write the word reaction? Can. So teacher, why cannot attack at the cyclohexane? It is attacking at the cyclohexane. If you look carefully, it is attacking at the H in here. You see that it is attacking at the H in here. Okay, so now this is the only product accepted. Okay. Okay. This one is prefer, yes, it is preferring to the tertiary carbon. Yes. There is 1 year in STPM that asks why is it that this is the major product? Free radical substitution reaction, this is the major product. Because a tertiary, you have to answer as tertiary carbon is preferable. Tertiary carbon is preferable. Very good. This is a very good explanation. Okay, very well done. Okay. Okay. So I draw BR in CH2, not accepted because the question 1 major product. So only this is accepted. Okay. Okay. So this is the only product accepted. Other than that, no. Okay. Other than that, no. Okay. No more argument. Because this is a way of how you should get your final product. Okay. Then number B, reaction of the methylhexene with bromine water. So type of reaction in here is electrophilic addition reaction. Without the word reaction, never mind. Teacher, can we write electrophilic additional? No, it must be electrophilic addition, not additional, addition. Okay, so if you write additional, then it's wrong. Okay, electrophilic addition. Teacher, can we just write addition without the word electrophilic? Also cannot. You must also have this one. How about minor? Minor, the question already said major. Do you see that? Label major product. So cannot, only major product accepted. Okay. Okay. So now as for this one, what is the major product for the reaction? So the major product of this reaction, because it's bromine water, so it must be OH and Br. And the OH specifically must be located at the tertiary carbon. This is a part of this Markov-Nikov rule. Now, Markov-Nikov rule, you have 2 definitions. Of course, the one of the conventional definition is saying that in the addition of HX to C double bond C, in the addition of HX to C double bond C, H is preferably added to carbon with more hydrogen. That is one of the definition. But actually, there is another definition of the Markov-Nikov rule. The second definition of the Markov-Nikov rule, it is says that nucleophile is preferably to be added to be carbon with more substituent. Okay, so the nucleophile that is formed later, it is preferably to add to the carbon with more substituent. Okay, or you say that the cation is preferable to stay at the carbon with more substituent. That is what Markov-Nikov rule tries to say. So that is why tertiary carbocation is the most stable carbocation. Okay. Okay, so electrophilic addition. Teacher, can I write electrophilic aromatic addition? This has nothing to do with aromatic. No, cannot. Okay. Okay, then for C, reaction with methylbenzene with bromine. So reaction is methylbenzene with bromine. So now, because methylbenzene, the methyl is autopara director. So if you look at the question carefully, the questions are stress the words products, products. So when they say products, that means more than one product. Okay, so I would usually recommend students to write both of them. So one is at auto position, one is at para position. Okay, so that is how you should go. Okay. Okay, so so that is the solutions for number B16. Okay. Okay, any questions so far? Which part in here that you can understand you would like me to repeat for you? Teacher, if do not write aromat, if do not write the word aromatic okay or not, there are certain years that they accept. 2017 or 18, they accept that without the word aromatic. But okay, it's like this. Whatever I shows you today, it is the safest answer. It is the safest answer that the marks won't get deducted if you mention this. Okay, so I dare not say that it is not accepted because it's accepted in one of the year 2017 or 2018. So in this case, if I'm a marker lah, definitely I will say boleh lah. Electrophytic is electrophytic substitution one, but sometimes they stress the word aromatic, but sometimes they don't. So for in your case, can. Okay. So is aromatic electrophytic substitution correct? Boleh lah, because we are not English one. We are science one. As long as there is electrophytic, as there is aromatic, that is the substitution, then okay already lah. Never mind lah. Teacher, if I draw 246 product, mana ada 246 only occur for 246 product. Usually occur only on the alcohol, phenol, and aniline, and it also specifically for bromine only lah. You seldom got 246 product actually. Okay, so don't give weird answer, please. Don't give weird answer. Organic chemistry is actually very static one. You cannot simply got additional things one. Okay. So can you repeat the definition of Markov-Nikov rule again? Sekejap lah, sekejap. Bukan tanah. Sekejap. Wait lah. The Markov-Nikov the Markov-Nikov rule definitions is actually quite common, but long time didn't ask in STPM also already, because at the end of the day, Markov-Nikov rule. Okay, so you lah, jangan cakap Mr. Chu tak ajar lah. Okay. Can? So there is the Markov-Nikov rules. Okay. So you can screenshot and then later you this one back again. Okay. So that is the Markov-Nikov rule. Okay, so that is for number 16. Markov-Nikov rule is opposite of Zayzev rule. Yes. Unorthodoxly it is opposite of this Zayzev rule. Okay, so because of the time constraint, so I cannot stay too long in here. So can I go on to the next one? Okay. Yeah, sure. Shall we? Okay, number 17. Coffee bean contain chlorogenic acid. Structure of the chlorogenic acid is given below. Now, this question is very, very challenging, I tell you. Why I say very challenging? Because it involves a lot of things in here. Okay, from the structural formula, from the structure, deduce the molecular formula of the chlorogenic acid. So if you count carefully, the molecular formula is C16H18O9. Okay, C16H18O9. Teacher, only aromatic without aliphatic, no need. Aliphatic, no need. Okay, so the molecular formula is C6H18O9. Okay, for more detail, teacher kena tunjuk. Okay lah. You know that each of these represent one C. So you have 1, 2. F1, C2, C3, C4, C5, C6, C7, C8, C, 9C, 10C, 11, 12, 13, okay, 14, 15, and then 16. Okay. Okay, about H, you have 1H, 2H. Okay, this one you have, this one you also have 2H. This one only 1H. This one only also 1H. You must know by yourself lah. This one also 1H. Okay. This one 2H's. Okay. This one 1H. Okay. This one also 1H. This one also 1H. This one also 1H. And then this one also 1H. Okay. Then the rest of the H you can eventually calculate is 18H. Okay. And then O9, O you can count by yourself lah. Obviously is 9 lah. Okay, so C6H18O9. Okay, in B circle the chiral carbon atom. So where is the chiral carbon atom? So this is chiral, 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 chiral. Okay, so there are 4 chiral carbon atoms. So the rest are not chiral carbon atom. Okay. Okay, C. Draw the structure of the product form from the following reactions with this one. 1. Sodium hydroxide under room temperature. Now, look at here. The questions are asking under room temperature. The questions are asking under room temperature. So room temperature, it is acid-base reactions. So teachers, how to draw stereoisomerism? Is it needed dash line and straight line? Straight line can. Straight line can. Okay. Can we focus on the question first? Later, if you have any questions, you can ask at the behind. I have Q&A session. Don't worry. Okay. I now focus on the questions. Okay. Sorry. Okay. So in here you must know by yourself that only carboxylic acid and phenol can react with sodium hydroxide. Carboxylic acid and also phenol can react with the sodium hydroxide. So this one can react. This one cannot. This one cannot. This one can. This one can. Okay. So that is why you have O and A. Teacher, can I write O minus or not? You cannot write O minus. In this case, if the question specifically uses sodium hydroxide, the question already specifically uses the word sodium hydroxide. So you must have Na inside there. You must have Na inside there. Okay. So you must write out as O and A. No need negative, positive. Positive, negative is actually not important. The only positive, negative which are important is the benzene diazonium. Benzene diazonium chloride. Benzene diazonium chloride, you must put positive, negative. The rest you don't put also, never mind. Okay. Should we need to write? No need to write the charge. Right? This okay. Like this also can. Okay. Same question. Okay. So shall we move on to the next one? Okay. So B, hydrochloric acid under reflux. So if it is under reflux, so then hydrolysis can take place. So here the hydrolysis will break off. Okay, and be careful. This one can also react with HCl because it's HCl. So this one can also react with HCl, C double bond C. Okay, so this is the tricky part of this question where most of the students, they will only focus on the hydrolysis, but they will neglect on the C double bond C part in here. So the two products that you form in here is actually this one when you break, this one you attach to H, this one you attach with OH. Okay. So one of them you form OH in here, and then the other one you form OH in here, and then HCl. One of them is HCl. Okay. So these are the two structure formed from the reactions in here. Okay. Okay, finally, number 3, bromine water under room temperature. Bromine water also very important. Bromine water, it can react with the for bromine water, use other color. Okay, bromine water, it can react with phenolic group as long as it is phenolic group. So here, and here, because you have 2 OH, from the angle of 2 OH, you form 2,4,6. Okay, so the 2,4,6 already occupied. So at the end, what will you form? So you form to form a 2,4,6-tribromophenol. So here we'll react with the bromine. Okay, and then another one, because it's bromine water. So this one, the C double bond C will also react with the OH and Br. It can be also the other way around, because both of them are secondary alkene. Okay, both of them are secondary alkene. So if you switch the OH-Br in here also can, no problem. Now the key in here, one must have Br, one must have OH. Okay, so that is the key in here. Okay. Okay, it's like I said, this question is quite challenging because it requires students to deep analyze a lot of things, and I purposely pull out so that this is for high difficulty level students. Okay, so if you're able to understand all this, then you are good to go already. Okay, okay. So with that, that is for question number 17. I admit that this is a little bit challenging this question. Okay. But never mind you just try you can understand very good cannot understand, never mind STPM, maybe will come out difficult question like this. I don't know, I cannot say for sure. Okay, so with that is the 2 questions for the structure. Okay, any questions so far? Can hopefully not much of a problem should be quite easy okay. Not to say quite easy should be quite general these are very common in the STPM. It's just that some small little details that student maybe they neglected it, so you don't know okay. Can shall we move on to the next one, essay question? Yeah. Okay, so hopefully you'll be able to understand so far. So if no problem, then let's move to the essay question, shall we? Okay, so for section C, 30 marks, you have answer only 2 questions. So you are advised to spend 20 to 25 minutes for per essay in this section. So do your best to present in an essay full with content related to the question. Point form, table, mind map is allowed during answering STPM, but not advisable unless you are confident with your answer. What does it mean in here is some students, you when you write point form, but you don't know what you are writing, then you better write in essay. But if you understand what you are looking at, very straightforward one. Most of the time, essay questions are very straightforward, especially for organic, because there are not many alternative way of answering for organic. There is only one way most of the time. Okay, so that is why if you can answer in a point form, then go ahead. Okay, or you can answer in a mind map, and all this and that. And whatever way, whatever strategy that you use for this, you can always, you can always put inside your answer paper. Okay, just write everything on answer paper. Okay. Okay, so hopefully you'll be able to this one. So with that session, shall we begin? Okay. Okay, so first essay question number 18A sounds like this. Phenylethanol CCH5COCH3 is an important chemical with many uses. So phenylethanol can be synthesized by using benzene as one of the starting material. Using suitable reagent and conditions, propose a mechanism to show how phenylethanol can be synthesized starting from benzene. Okay. So how do you propose a mechanism for to show how phenylethanol is synthesized starting from benzene? Okay, so here you definitely are going to first use this one. Why M straight away M2? Okay, so in here, the moment that you mention that your reagent and conditions the moment that you mention your reagent and condition, because the question one using suitable reagent condition. So the moment that you write CH3Cl, COCl in AlCl3, this is your first mark already. Okay, this is your first mark. The moment that you mention CH3COCl in AlCl3, this is already the first mark. Okay, so the second mark goes to, you have to show the arrow on how does the Cl go, heterolytic fission take place where the CCl is broken, and then you form the intermediate of the AlCl4 minus. Okay, so the moment that you form the strong electrophile, then this is the third mark lah. Okay, so second mark goes to the arrow, third mark goes to the intermediate. How you form the strong electrophile. Okay, then the fourth mark will goes to how the pi electrons inside the C double bond C attacks the partial positive carbons in here, and the fifth mark goes to the formation of the intermediate, the carbocation forms during the reaction. Okay, the fourth mark show the arrow of how do the benzene C double bond C attacks the carbon. You form the intermediate of HCOCH3 in here. Okay. Need to use reversible arrow. What do you mean reversible arrow? Only one-way arrow, and the arrow must always from negative to positive. What does it mean by negative to positive? It must be from the place where the electron is broken. Okay, electron is broken to here. Okay, and this one must be from negative to here positive. Okay. If I must be from the pi electrons to the positive, from negative to positive, I usually tell the student like this, from negative to positive. Okay. For LCL3 equation. This one, no need. This one reversible doesn't matter. This one can, this one also can. Okay. Both can. Reversible not important. Okay. Okay. So now this is you form the carbocation. And then finally you have the deprotonation. Deprotonation. So deprotonation in here is you undergo heterolytic fission in here. Okay. Then the Cl will attack the H, and then the H deprotonate to form back the C double bond C. So that is how you are going to show the mechanism of this one. Teacher, I see in some of the books, they use these methods. Let's say from this case, so teacher, I see some of the old books, they draw like this, teacher. They use the arrow, head arrow, and then you use C plus, double bond, O, CH3. Is this method still acceptable in STPM? From the year that I marked about this, we no longer accept these methods already. Okay, when you draw the arrow and you form this intermediate. Sorry, my drawing is a little bit bad. You form this kind of the intermediate inside the middle got positive one. Okay, so this is no longer accepted in STPM. We don't accept that the STM. Okay. Is it we must use Kekuli structure, and do we need to draw the resonance structure? No need. Resonance structure no need to draw. What does it mean by negative to positive? Negative to positive, actually no need lah. Negative to positive. It is from, how to put it, what's a negative positive? It is from electron to the partial positive partial positive lah. That is how I describe lah. To be honest, I do not find I cannot find a suitable words for it. But all I can describe is from something negative, from the, okay, can I go say like this? From the nucleophile to the substance that is about to accept the lone pair electron. Okay. So that is what I mean by negative to positive. From Lewis base to Lewis acid. Okay. From Lewis base to Lewis acid. Okay. Okay. Need to mention reflux. Can. Must mention reflux. Thank you very much. I forgot to mention the reflux here. Actually, must require reflux. Okay. Teacher must write slow, fast or not? No need. But if you want to write slow, fast, go ahead. You want to write slow, fast, go ahead. Okay. So far we seldom stress on slow, fast, but to play safe, then why not, right? Okay. Is that from high electron density? Yes, also can. Very good. Yeah, 3. High electron charge density to low electron charge density. Yes, also can. You can also describe like that. Okay. That's why I say from negative to positive. Okay, thank you very much for helping me to explain. Okay, well done. That means you understand now from where to where. Okay. Okay, so that is how you are going to answer for these questions. Okay. Okay, so that is for number 18A lah. Okay. Okay, so immediately we goes to 18B. Okay, diagram below shows some of the reaction involving phenylethanol. Phenylethanol typing error lah. Okay. Based on the diagram, 1, state the reagent and condition for A and B, hence draw the structure for both orange and yellow precipitate. Okay, so the A in here is 2,4-dinitrophenylhydrazine. Teacher, can we put 2,4-DNPH or not? No, you cannot put 2,4-DNPH. Though, alternatively, you can set Brady's reagent. Brady's reagent we accept. Yes, Brady's reagent we accept. We accept Brady's reagent. Okay. Or you can draw the structure of the 2,4-dinitrophenylhydrazine. So as I shows to you inside the slide here, so that is the 2,4-dinitrophenylhydrazine. Okay. Okay. As for the structure of orange precipitate, so you have to draw the structure of the orange precipitate. So looking like that. Okay. So as for B, B is yellowish precipitate. So in here, because you know that this is a carbonyl compound, so orange precipitate is definitely coming from Brady's reagent, and yellow precipitate is definitely coming from the iodoform test. So there are no other else color already. Okay. If silver mirror is for aldehyde, same goes with the brick red precipitate. Also comes from aldehyde. So in here, when we just write orange precipitate, yellow precipitate, students, you must know by yourself that they are referring to all these tests. Okay. So we will not tell you any further already. So you must know by yourself. Okay. So the yellow precipitate in here, the reagent condition is alkaline iodine solution. You can write I2 in OH minus also can, no problem. Okay. And the yellow precipitate is not the product of the organic. The yellow precipitate is due to the formation of CHI3. Okay. Okay. So this is for number 1. And then number 2, phenylethene can be prepared from phenylethanol via a 2-step reaction scheme. Propose the reagent for CD and hence deduce the structure of the compound X in here. So C in here, in order to form alkene, you must first reduce to form alcohol first. So you must use reduction LiLH4 in dry ether followed by H2O+. Then you form this secondary alcohol. Then you undergo dehydration where you use concentrated sulfuric acid. So you form the alkene in here. Okay. Very, very straightforward reactions. Very, very straightforward reactions. So there is no other else method other than this already. Okay. So students, you must know very, very well how does the reactions going on in here. Okay. Okay. So any questions in here? For B? Okay. Okay, so no problem. Then we goes for C. Phenylethene is a starting materials used to synthesis, produce a synthetic polymer, which is widely used widely in the world, commonly known as polystyrene. So draw the structure of polystyrene with 2 repeating unit and state the type of polymerization. So you must be able to state addition polymerization. Okay, question said that draw the structure of polystyrene with 2 repeating unit. So you must draw 2 repeating unit and then you must put the bracket N. Okay, you must put the bracket N here. Okay. Sorry. You must put the bracket N to show that it is polymer. Okay, so and then this is how you draw the 2 repeating unit. Okay, 2 repeating unit in here. So for more information of how you are going to draw the polymer, you can go to my YouTube. My YouTube teaches you on how to recognize the way of how you draw the polyethylene in here. Okay. Okay, so with that, that is for the questions for number 18. Okay. Okay, any questions for number 18 or not? Which part in here that you cannot understand or let me to repeat further? Or you have any proposed methods that you want to propose? We can discuss here, no problem. So for the mechanism part, you must well verse in free radicals, substitution, electrophilic addition. Just now in the early part, in the objective, I already shows you the hydrohalogenations of the alkene, isn't it? So try to familiarize with that. And then last but not least, nucleophilic substitution. SN1, SN2 long time didn't ask already. So try your best to draw them. Okay. Okay, so if you buy my module, at the end you got short notes there. You can see that the short notes there. Okay, so with that, that is for question number 18. Okay. Okay, so shall we move on to the next one? Teacher, how to differentiate addition and condensation? Addition polymerization, you have addition is usually C double bond C lah. Condensation, you must have either carboxylic acid derivative react with the either diamine or diamine or diol. Okay, so that is how you distinguish between addition and condensation. Okay. If you want, I'm so sorry lah. If you want to know further detail, you really have to go through the reactions in there and use. Try your best lah to know. Okay, sorry lah. You can also go to the YouTube, my YouTube, to see what is the difference. You can also search in YouTube lah, how to distinguish addition and condensation polymerization. Okay, so with annexation, let's go to number 19. Number 19 is a little bit challenging. Most of the students, they will answer number 19 because number 19 will have this, how to calculate empirical formula, molecular formula. Students love this question, I tell you. Okay, so, but then behind that later, they don't know how to answer already. Okay. Okay, so never mind. Let's have a look at the question. Tartaric acid is a dicarboxylic acid commonly found in grapes. From an analysis, it was found that tartaric acid contained 32.0% of carbon, 4% of hydrogen, and 64% of the oxygen by mass. Given the molecular mass of tartaric acid in 150, use the information above to calculate empirical formula and hence molecular formula of the tartaric acid. So you definitely use this one, the CHO, the period, the table methods to calculate empirical formula. So empirical formula, as you already eventually deduce, it will become C2H3O3 lah. So since the ratio of CHO is 2 to 3 to 3, so 12 times 2 plus 3 times 1 plus 16 times 3 power of n is equals to 150. So you get n equals to 2. So the molecular formula is C4H6O6. Okay. Now, if you read carefully at the questions, the questions already said it is a dicarboxylic. Now, the question already said that it is a dicarboxylic acid. So dicarboxylic acid, now because your molecular formula, you have C4H6O6. So dicarboxylic acid means that you must have 4C. Okay, try your best to draw like this. You must have 4C. Okay, and then 2 of the C. First one and the last one must have dicarboxylic acid. So you must have OH and OH. Okay, now if you count carefully, now you already have 4 O, 1 O, 2 O, 3 O, 4 O, okay? But you have altogether 6 O. So H also 1 H, 2 H only so far. Okay, 2 H only so far. So how to put remaining 2 O and also 4 H's. So in here, either you put both of the oxygen as here. So you put oxygen here. We rarely have carbon having 2 oxygen at the same time. Why do we say is that we rarely have carbon have 2 oxygen OH at the same time like this? You cannot have this, actually. You cannot have both of the C and the same OH, cannot. Why? Because eventually it will become C double bond O. Because eventually it will become C double bond O. Now this is discussed during the hydrolysis of the haloalkane. Okay, this is discussed during the hydrolysis of the haloalkane. So it is unlikely that the both OH is at the same C. So this cannot happen. Okay, because the reactions eventually will give a ketone. Okay, this is a very, very small subtopic, and there are not many places that explain about this. So I hope that you will take notes on this one. Still cannot understand, you can go to my YouTube on the this one. How come the empirical formula is C2H3O3 and not C3H4O4? I don't know how you get C3H4O4. I don't know. If you divide by the smaller small, right? Okay, smaller small, this is 1. This is 3. This is 1. This is 1. This is how many? 3/2. Sorry. This is 2/3. Sorry. This is 2/3. This is 2/3. Am I right? 3/2. 3/2. 3/2. 3/2. Sorry. 3/2. 3/2. Terbalik. 3/2. 3/2. Yeah lah, 1.49, which is 1.5 lah. Okay. So 3/2. 3/2. Eventually you get H3O3 lah. Okay. So this one 1.5 lah. 1.5 lah. Okay. Okay, so can okay, so how does then finally back to the structure. So this one is H log. You have 4 more H mark around not. So this one is H, this one is H. Then this carbon not yet complete ma. So this is your H, this is your H. So this is the only accepted structure already. No other than that anymore. Okay, because as I already mentioned, you cannot have 2 OH at the same carbon. Cannot. Eventually it will become a carbonyl compound. Okay, so that is why in this case, students, this is a very challenging question, and this tartaric acid was actually asked in STPM 2015 last time. Okay, so the full name for this, we call it as 2,3-dihydroxybutane diuric acid. 2,3-dihydroxybutane diuric acid. Okay, so how to name diuric acid? You have to refer back to my YouTube's on carboxylic acid. So I explained that. Okay. Okay, so that is how you are going to deduce the molecular structure and the IUPAC name for the 2,3 like this one. There is no other structure other than this anymore. Okay. Butane 1,4-diuric acid cannot. Butane 1,4-diuric acid can. Sorry, butane 1,4-diuric acid can. Butane 1,4-diuric acid is old naming. It's old naming. Okay, new one no need 1,4 because guarantee if you call it as a butane diuric acid, it's guaranteed occupying the first one and the fourth one. But still, we accept butane 1,4-diuric acid. Yes, we do accept. Okay. Butane 1,4-diuric acid is old naming. It's old naming. Okay. Okay, so then we go to number C. Tartaric acid can be prepared starting from ethane diuric acid using suitable reagent and condition. Propose a reaction scheme to show how tartaric acid can be prepared from ethane diuric acid. So this is the ethane diuric acid. So you must know about the ethane diuric acid. And then eventually this one, you see from 2C to become 4C. And then this 4C, I draw out the structure again so that, wait, let me erase. Okay, wait. I'm going to cancel the last animation. Okay. So now, how are you going from how do you from this 2C synthesis to become 4C? And then one of the things that you have to take notes is you contain CHCOH. We call it as an alpha carbon. Okay. Student, you have to know by yourself the only way to synthesize both OH and COH at the same time is actually coming from this HCN. Yes, is only coming from HCN. And HCN can only be synthesized using aldehyde, carbonyl compound. Carbonyl compound, either aldehyde or ketone. No other thing else. This is something that automatically, student, you must know by yourself. Okay. If you want to synthesize some carbon that have OH and COH, we call it as alpha carbon. This only way to synthesize it is from carbonyl compound react with HCN. Okay. Okay, teacher, can we write as 2,3-dihydroxybutane dicarboxylic acid? Macam boleh. Macam boleh. Arguably can lah. Arguably can lah. Arguably can lah. Boleh lah. Boleh lah. Can lah. Can lah. Can lah. Can lah. Dicarboxylic. But usually we don't say butane dicarboxylic acid. Okay, I don't know. I don't know. It's arguable. It's arguable by the lecturer. I don't know. We never said like this. Okay. But in STPM 2015, there's 1 year that asks about the citrus acid. Citrus acid is this 1,2,3 tricarboxylic acid. That one is out of the syllabus. So actually that year, the structure question is 7 marks, but we managed to find 8 marks for that structure question because we want to cover back the name of this one. There are not many students who know how to name that. So don't be troubled by the terms like carboxylic acid. And because of that 1 little year, that 1 single mark, you keep troubling in your mind. Will it come out again? Will it come out again? Don't think too much about that. It's not up to you already. Okay, that's the most important. Okay, so back to the questions in here. So in here, you must start from ethane diuric acid to synthesize this. So in order to become carbonyl, you must first reduce to. That's why I said don't get too possessed, don't get too obsessive, or don't get too possessed over one question for then 1 mark already. Cannot answer, then let go that 1 mark. Okay, cannot answer, then let go that 1 mark. That is the only year only. Okay, don't worry about that. Okay. Okay, so back to the question. So first you have to do reduction to form alcohol. Okay, so you form CH2OH, CH2OH. Then after you form alcohol, you react with PCC, or you use copper at 400 degrees Celsius, also can. So you form your aldehyde. Then you react with your HCN or KCN under H+, or HCN in NaCN also can. Many ways to represent. So you form the cyanohydrine. And then finally, you use acidic hydrolysis to form your desired products in here. Okay, so that is how you are going to synthesize this. Okay, so they are very specific, and this is the only way. There are no any other methods proposed already. That is why organic chemistry is difficult in this part, because there is only one solution. Most of the time, we look for the shortest way to synthesize organic compound. We always look for the shortest and simplest way to synthesize organic compound in here. Okay, so this is the only way to get to synthesis tartaric acid from butane diuric acid, ethane diuric acid. Okay, set marks. Okay, so that is for number C. Okay, and then KCN must actually it's HCN in KCN. HCN in KCN. HCN in KCN. Actually, that is the correct one. HCN in KCN. Okay, so just a chemical test to distinguish ethane diuric acid and tartaric acid. This is the only accepted year. At 2015, when we argue, can we use KMnO4 or not? They said cannot. So this is the only one accepted already. Okay. Teacher, how to determine? So KCN, okay, like I said, the key is HCN. HCN is the main key, okay? And KCN is a catalyst. HCN in KCN. So H is a key, because this is a nucleophilic addition. Nucleophilic addition, okay? What does this HCN in or KCN/H+ means? Because this is nucleophilic addition. Okay, you must have H and this one. Okay, teacher, if I use if I use KMnO4, can only use copper at 400 degrees Celsius because you only want to form aldehyde. So you can only use copper at 400 degrees Celsius, cannot use KMnO4. Because KMnO4, if this one, it will become carbon dioxide and water. Okay. So how to determine the marks for the reaction scheme? Usually, reagent condition 1 mark. In this reaction scheme, usually this one 1, 2, 3, 4, 5, 6, 7. They are just nice. Reagent condition 1 mark, intermediate 1 mark. Reagent condition 1 mark, intermediate 1 mark. Usually it's like that. Okay. Okay, so can we move on to this one? Okay, so what is the chemical test to distinguish between ethane dioic acid and tartaric acid? So this is a special chemical test only used for the ethane dioic acid. There is a very small subtopic in this carboxylic acid where you have methanoic acid and ethane dioic acid. So you can only use the chemical test inside there only. And both of them can react with KMnO4 can react with both tartaric acid and this ethane dioic acid. Both of them can react. So they cannot use KMnO4 to distinguish in between these two. Okay. Okay, so with that, that is how you are going to solve for question number 19. Okay. Okay, what else questions you have in your mind? You can always ask, no problem. Okay, can Okay, so if no problem, then we go to the final essay question, which is essay question number 20. Butamben is often used for treatment of chronic pain. The molecular structure of butamben are shown below. Is sorry. Hey. Okay, is Lucas reagent can be used? Lucas reagent ialah apa forgotten already. Lucas is what already? How come I forgot already, Lucas? Lucas reagent cannot. The only HCl in SN. Mr. Chu Bengong already. Okay, thank you very much. Lucas reagent cannot. No, cannot. Can we write equation for the reaction scheme separately? Because some answer in the past year book, they write equation separately. Okay, it depends on the questions. Sometimes if the question asks to propose reaction scheme, nowadays it's very direct. Write equations to show how the reaction, then you have to use equation by equation. Propose a reaction scheme, then you propose a reaction scheme. They are very direct at the questions. So answer according to the question. That's what I try to tell you in here. Okay. So teacher, better put KCN or KCNH plus, which one is better? Use HCN in KCN. HCN in KCN. The one that you learn in your chapter 6 is HCN in KCN. That is the best. Okay. This KCN in H plus is alternative accepted by lecturer. Okay. Okay, but Lucas reagent cannot. The only way to distinguish between ethane dioic acid and also tartaric acid is only concentrated H2SO4. If you look into this one, there's only 2 reactions of the ethane dioic acid. One react with KMnO4, but both can react with KMnO4 And then the other one is this concentrated sulfuric acid. Okay. Okay, then number 20, butamben can act as a base. Compare the basicity of butamben with that of the ammonia. So in here, so you say that ammonia is a stronger base than butanban. Okay, so due to amino group is in butanban bonded to phenyl group, which act as an electron withdrawing group, and then therefore causing the nitrogen to be less ready to accept proton. By the way, you can also say butanban is a weaker base than ammonia. Also can up to you. Okay, butanban is a weaker base than ammonia. Okay, okay. So so there's the 3 marks in here. How you are going to answer for A? Okay. Okay, so B, draw the structure of the product formed when butanban react with the following reagent and condition. Number 1, if you react with bromine water, and number 2, if you react with aqueous sodium hydroxide. Benzene 1,4-dicarboxylic acid and not benzene 1,4-diuric acid. I don't know. I don't know where you heard this from. This is STPM 2015 Sem 2, Sem 3. The only accepted answer is benzene diuric acid. Oh, okay, okay, okay. No, no, no. Whatever. Okay, bromine water. Okay, so in bromine water, because of the NH2, you react with the. Oh, sorry. Okay, so because of the NH2, you react with the 2,4,6 tribromophenol, but since 4 is already occupied by the ester already, so you can only react at the position number 2 and position number 4. So that is for number 1, and then number 2, aqueous sodium hydroxide under reflux. So if aqueous sodium hydroxide under reflux, so inside here the C double bond C will be broken. Okay, sorry. Okay, so the COH will be broken at here, hydrolysis occur. So this one you form OH, this one you form H. But because this is sodium hydroxide, so sodium hydroxide can further react with the carboxylic acid in here to form the this what this one. So you form NH2CONA, and then you form CH3 CH2 CH2OH in here. Okay. So that is for number 2. Okay. Okay. So that is for 20A and 20B. Okay. Okay. Then for 20C, aqueous hydrochloric acid under reflux. So again, so this is also an acidic hydrolysis. So you break here. So this is your OH, and then this is your H. Okay. And then because this is using HCl, so this alkaline solution can also, this basic can also react with the HCl in here. So at the end, you form NH3Cl and COH, and then you form CH3, CH2, CH2, CH2OH. And then finally, number 4, reduction of the LiLH4 followed by acidic hydrolysis. So in here, when you reduction, because the reduction goes to ester in here, so when you reduce ester, both of them will become alcohol. Okay, so this one will further reduce to become CH2OH. Okay, so this one will further reduce to become CH2OH. So you at the end you form NH2 CH2OH, and then you also form CH3 CH2 CH2COOH. Okay. Okay. So that is how you state the reaction. Okay. Any questions or not so far? Why NH3Cl and teacher, why is it that why NH3Cl not NH2? Because you add HCl. This is an acid-base reaction. This is an acid-base reaction. Okay, so you add HCl inside there. These are acid-base reactions. Huh? Okay. What else? Now, LiLH4 cannot reduce the benzene ring. Cannot. LiLH4 cannot reduce in benzene ring. In fact, in the benzene ring, if you want to reduce to become cycloalkane, you can you use hydrogen in nickel, high temperature, high pressure. High temperature, high pressure is a must stress. Okay. Okay, so that is for 20 B3 and B4. So teacher number 4, why the NH2 no need to become NH3 got acidic hydrolysis? Yeah lah, actually got acidic hydrolysis. Yeah, you are so far you're correct. Maybe why NH4 cannot react? Acidic hydrolysis. Yeah lah, can. Must put NH3Cl lah. Okay, you form NH3Cl lah. Okay, you form NH3 plus lah. Okay, yeah, correct. Okay, but I'm not sure whether they will. I think they will also this one. Okay, so can I correct this one? NH3 plus. Thank you very much for helping me. Supposedly NH3 plus because it's acidic hydrolysis. You're right. Okay, thank you very much for helping. Okay, NH3 plus in here. Okay. Cannot write as NH3 plus. You mean C? Is it you mean number 3? Yeah. Cannot, because question specifically uses hydrochloric acid. If the question already specifically uses hydrochloric acid, then you must also use HCl. Cannot write NH3. They will penalize that because the question already said HCl. Okay. Okay, so can we go to the last one? Okay, so butamben is often used for the treatment of chronic pain. The molecular structure of the butamben is as shown below. So starting from aniline, using suitable reagent and condition, propose a reaction scene to show how butamben can be produced. So you start from the CCH5 and H2 lah, okay? Aniline. Then first you do, because this is a carboxylic acid, so and this is ester lah, so you must synthesis to become benzoic acid, and then you do esterification. Okay, so you use CH3Cl in LCl3, so you form NH2 in the COH, then you undergo KMnO4 oxidize, you form the carboxylic acid. And then the carboxylic acid in here, you further react with alcohol with concentrated sulfuric acid. I know lah, some of you must ask, teacher, why it will not affect the NH2? So in this case, we focus on the esterifications in here lah. Okay, so that is the how you are going to synthesize the ester in this case. Okay, so as mentioned, each intermediate reagent condition 1 mark, intermediate 1 mark. Why don't use benzoyl chloride? No need to use benzoyl chloride. If you use benzoyl chloride, then you will provide additional steps. Furthermore, we are not reacting with phenol. If you react with phenol, then yes, you must use acyl chloride. Yes. Okay. Okay. So with that is for essay question number 20. Okay. Okay, so with that, I finished the discussion for all my questions already. Of course, these are just trial examination. I treat it like a trial examination. So the most important part is you try to practice, do more questions and all this and that. So for the remaining 2 days, I would suggest that you all look back at the past year question, try to understand the trend of how the past year question asks. Teacher, can I write CH2 in CH2? Try not to write that. Try not to write like that. Try not to. It's not difficult one. Unless it's 17, 16, 17. Then you write can, but this is only 3 carbon, so don't shortcut like that. Please don't. Okay. Teacher, when writing reaction scheme, can we write the reagent, the symbol? Yeah, can, no problem. You can also, I know what you're trying to say. You are trying to say as if like, teacher, can I write like this or not? Let's say plus CH3Cl, draw an arrow, then AlCl3. Is it like that? Can, no problem. Can. Doesn't matter lah. Can. Okay. Doesn't matter. Also can, no problem. Can. Okay, any else questions? Okay, so with that we finish the discussion. Okay. Okay, so I go to this one, Q&A. What chapter possibly I don't want to predict. Can write branch CH, must use CH. Can write branch as CH, can. Because there are 4 ways to represent your organic structure. So the one that you are mentioning is the Lewis way lah. The Lewis way. Can, no problem. Can. You can one by one show, no problem. So how to name conjugate acid or conjugate base? What do you mean how to name the conjugate acid or base? Or ammonium salt, you mean ammonium? Ammonium. If NH2 in benzene, we call it as anilinium ion. Anilinium ion. Okay, anilinium. 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 For drawing part, can we use pencil? Can. No need to use pen. Can. Okay. Can use pencil, no problem. You won't get penalized drawing the structure in pencil. Okay, so I have Q&A. So you can throw in any questions that you want. Okay. So Q&A. Sorry, Mr. Chu, put in this one. Okay, anyone if you want to donate, feel free to scan. Okay. Okay, so Q&A sessions ready. Okay, does ethanoic acid form positive? No, cannot. Only methyl alcohol and this one, carboxylic acid, cannot. So can you explain the definition of Zaitsev rule? Can, no problem. Wait, give me 1 minute. Okay. Okay, so this is the definition of the Zaitsev rule. Okay. Okay. So I hope that I explained all this one. Okay. If draw with pencil, examiner will still yes lah, can lah. So usually for conjugate acid, we add IUM at the end. Most of the case, if amine, then aminium. Amine is aminium, if I'm not mistaken. Okay. For esterification reaction, is the reversible arrow is a must? Not necessarily. Not necessarily. So if in exam I cannot remember the exact temperature or atmosphere, can I just write high temperature, high pressure? Actually, no need to memorize. The only temperature, there are only 2 temperatures that I want you to, I usually recommend my student to remember. One is the copper at 400 degrees Celsius, and another one is the NaNO2 in HCl 0 to 5 degrees Celsius. The rest just put reflux, okay already. Okay, the rest just put reflux already. Unless you want to really go and remember some very specific temperature pressure, such as if you still remember, there is this hydration of the alkene where you use steam in the H3PO4. Then they say 170 degrees Celsius, 60 atmosphere. That one no need. For hydration, just write dilute sulfuric acid under reflux. Steam in dilute sulfuric acid under reflux, okay already. Don't have to complicate it. So if temperature wise, only two temperature that you need to remember. One is if you use copper at 400 degrees Celsius, and another one is NaNO2 in HCl 0 to 5 degrees Celsius. Can already. Okay. Can I use K2Cl2 instead of KMnO4? K2Cl2O7 usually is for alcohol only lah. The rest, alcohol only lah. Alcohol only. Okay. So how to remember if substituent is electron donating or electron withdrawing? Why you want to remember electron donating or electron withdrawing? Oh, you mean to explain the acid base, is it? If acid base, in acid base reactions, you just need to understand how to put in words. In acid base reaction, actually the only one that will influence the acidity or basicity, only these few: chlorine, NO2, CH3 lor. So there is this very unorthodox way to say that NO2, okay, just in our STPM context, I can STPM context, we have this OH, NH2, CH3, Cl, and also NO2. So NH2, OH, CH3, Cl, all of them will increase the acidity. No, sorry. Cl and also the NO2 will increase the acidity, and then CH3 will decrease the acidity lah. Okay. Actually, no lah. Don't think too much about that. Only a few only lah. Okay. So sorry lah. I can only say that. So if you want to find out more, you can. Okay. So can you explain the acidity and basicity? A bit confused. Okay, wait lah. One moment. Wait lah. How to put in words? Acidity and basicity. Wait lah. Okay. Okay, so I'm just going to focus on the acidity only lah. Okay. Now there is this later you screenshot this diagram on your own. I'm going to put off your comment. You can screenshot this. This is the I put it in a very summarized table. This is the way of how you describe about acidity and basicity of the organic compound. Okay, and this is the continuation from there. Sorry for that. Okay. So because it's going to take a very long time to explain acidity and basicity, so all I can do for you is I put this slide for you. Okay, and then you screenshot this. Yeah, temporarily I just remove. Okay, so later you screenshot this and then you study on your own. So that is what I can do the best for you already. Okay. Okay, so for dehydration, H3PO4, dehydration, you use concentrated H2SO4. Don't use H3PO4. H3PO4 is not for dehydration. H3PO4 is for this, hydration. Okay, H3PO4 is for hydration, not dehydration. Okay, don't confuse. Can I ask about writing the reaction scheme? Is a reactant or upper arrow or down arrow? Doesn't matter lah. As long as you write the flow scheme, okay already lah. It doesn't really matter you write upper arrow or lower arrow or we are looking more on the what is the outcome of your reactions in here lah. How to know question 1 auto para position if the question didn't mention about it? Write both law. Write both lah. Both question, both auto para lah. Ring activate or ring deactivate, I guess. No lah, what she tried to say is sometimes the question 1 auto, just now in question 16, 16C, products ma. So if you want to play safe, you write both lah. Sir, is QB still in the process of the syllabus? I think yes, it is still in the syllabus. Yes, QB process is still in the syllabus. Yes. So why only hydrogenation of peroxide called anti-Markovnikov? Huh? Hydrogenation of peroxide, apa itu? Tak faham. Can you explain in more detail? Why? Because I don't understand your question. I'm so sorry. Hydrogenation of peroxide. And where got peroxide? So far, we don't use peroxide in our content. Sorry, I don't know where you get this from. We don't use peroxide. Okay. So is basicity of amine different in gas form or in aqueous form? Acidity basicity can only be shown in the aqueous solution. Yes. So we will broadcast until 4:15. I have another 8 more minutes. Okay. Come. Ask. Sir, is the O no need to bracket? No need. Instead, in fact, if you write bracket O, but the key in here is KMnO4 slash H plus. Bracket O, bracket H, not important. About the acidity basicity, if you go through my module explained in quite detail. If you didn't buy my module, never mind. You can always go to the YouTube. You can go to the YouTube there. If write KMnO4 H2O plus, actually, I tell you, acidic hydrolysis acidified whatever all right, H3O plus is the safest. Yes, actually, this is the safest way. Because sometimes H3O plus, it is acidified. It can also be hydrolysis. So the safest way is to write H3O plus. Okay. Repeat unit need N. Repeat unit no need. Like in the example just now, for the just now what question already? 18C. 18C. If the question said, give me one moment. Do I have that or not? If the question did not start from the word, do I have questions for that or not? Let me see. Okay, wait a second. I'm going to search for you. Now in STPM 2000, STPM 2013, this one. Wait, let's share it with you. Yeah, I'm going to share it with you here. Okay, so So this is STPM 2013 semester 3. The question said, draw the structure of repeating unit. So the question in here, the question 1, repeating unit of polymer. Now, notice here, the question said, repeating unit of polymer. The word repeating unit come out first. If the word repeating unit come out first, you put bracket N, then it's wrong. Okay, then it's wrong. Okay, so you put as like this. Okay, you put as like this. Okay, so this is 2013 semester 3 lah. Okay, but if the question said, like just now, polystyrene with 2 repeating unit, the word polystyrene come out first, isn't it? Then you have to put bracket N. So that is when you need to put bracket N, when no need to put bracket N. Okay, I hope that it solves your riddles lah. Okay. Is there any tips to draw all isomer of the molecular structure given in the question? Okay. How to put in words? Always remember especially in essay I'm talking from the angle of essay questions okay. If the question ever says that if the formula contains C8H9, if the ratio of the carbon to hydrogen is approximately 1:1, then you must always mention this. Since the ratio of carbon to hydrogen is approximately 1:1, then X contain benzene ring or contain benzene. You must always mention that as a statement. Don't care where the marks located. As a student, that is not your task. Your task is to write everything down. Okay, so if you see from your structure C8H10, C8H9, C8H11, so automatically it will contain a benzene ring. C6 and above okay, and the C and H ratio is approximately 1:1, then definitely you contain a benzene ring. So the rest, it will depends on your test. The test to shows the compound, okay? And about that, I'm so sorry this last minute, there are many things that is hard for you to this one. Okay, later I will attach another link inside this YouTube. I prepare a table that you have to know what reagent and condition react with what functioning group okay. Some of my students they receive it already. I also attach that okay. So that's what I can think of to help you I'm so sorry okay. So it got in oxidation, right? O or KMnO4. KMnO4, don't put bracket O. Please don't put bracket O. Please don't put bracket O. Okay. So it's Lucas test in the syllabus. Yes. Lucas test is in the syllabus. In fact, the Lucas test is to for tertiary alcohol, tertiary or secondary alcohol. You cannot use PCl5. To test alcohol, cannot use PCl5 or SOCl2. Cannot. We argued that before 1 year that how to test alcohol. They want Lucas reagent. They don't want this PCl5 or SOCl2. They said that imagine if this experiment is to carry out in laboratory. So if everybody use PCl5 or SOCl2, you release a lot of hydrogen chloride, then you create tear bomb gas already. So that is why they only accepted for test of alcohol, alkyl alcohol, they prefer Lucas reagent. Okay. Teacher, is it we need to balance all equation? Actually, organic chemistry question mostly no need balance. The only equation that is needed to balance is acid-base reaction. That one we stress mostly on acid-base reaction. If the rest, for example, reaction with the what? Okay, like this. Generally, when we say that there is especially elimination reaction, condensation reaction. Okay, elimination and condensation and neutralizations. In elimination, you eliminate a small molecule, correct or not? So the side product of the small molecule must right. Same goes with the condensation reaction. So condensation reaction, you react with 2 organic compounds to eliminate a small molecule, correct or not? The condensation reaction, you eliminate a small molecule. That one must also right side product. And then for neutralization, so neutralization, because you want to find out how many mole to how many mole, so neutralization also need to balance. So the rest such as oxidations, hydrolysis, reaction with the iodoform test, a lot of tests, a lot of chemical tests, all chemical tests no need to balance. All chemical tests no need to balance, okay? Okay, which one is correct? Zaysel or Zaysel? Same. Russian, confusing. So is it compulsory to put physical state? No need, not compulsory. When draw isomerism for optical activity, do we need to draw the dashed line of the tetrahedron? No need. Just put one straight line like that. Just put for example like this. Guys, you have C, you have A. Draw in a slanted line like this B, X, Y, Z. Enough already like this. Then always remember to put asterisk in here Okay already like this. Okay already. Good enough already. Okay. Okay, is Sem 3 most difficult? Hey, I tell you, organic can be the easiest and can be the most difficult. You can score A easily, you can score F easily. If you understand, you can score A. You cannot understand, you score F. That is what I always tell my students. Okay. So if the mark asks to balance the equation, we don't need to balance. Usually, organic chemistry don't ask you to write balance equation. They won't even stress that in the first place. Okay. So only neutralization need to balance. Yes. Neutralization need to balance. Yes. Do we need to put asterisk on the chiral carbon atom? Then I just put for you. Tolan and Felling need balance or not? No need balance. But instead, actually, if like Tolan reagent, Felling solution, the most important is the side product. Can I show you this one? Give me 1 minute. Sorry, give me 1 minute. Okay. Okay, so in here, if you look carefully at the equation, if let's say you want Felling solution, just write for Felling solution, just write this. The key in here is writing Cu2 plus. Sorry, the key in here is writing Cu2 plus OH minus under reflux. Write out the product and write out the brick red precipitate Cu2O. If it is a tolerance reagent, this is more important. Okay, this is more important. You have to write out the tolerance reagent. You write out the product. You write out the product in here, silver mirror. And then alkaline iodine solution also the same. But alkaline iodine solution, sometimes they use the word sodium in iodine in sodium hydroxide. If the question contains iodine in sodium hydroxide, then you must put Na. If no, then just put like this okay already. No need to balance. Nobody asks you to balance the equation. Okay. Okay, so should we put square bracket for polymer or normal bracket? They don't really stress on that. Don't worry, both are accepted. Oxidation need to write the product, no need. Okay, what else? Okay lah. So I guess that is all for my talks today. I hope that this is what I can do the best for you already lah. I keep my promise to you, and then I try my best to give you whatever I can. So hopefully you all will be able to do well in your STPM semester 3. So I wish you all the best. Good luck, and then. Okay, so good luck for your future, no matter which university that you go to. I wish you all the best. And then finish this Sem 3 lah. Good luck on Monday lah. Okay, for question and answer, later I'll put suggested question and answer in the group lah. If you are following certain groups that you know lah, which group you belong to, I'll put the answer inside there on the Monday lah. Okay. Equation balance, no lah. Don't worry about that. Question, condensation. Usually condensation reaction is it's balanced lah. It's balanced. Don't worry, because you only remove one small unless you are two or more groups inside there. If not, the keyword in a condensation is to eliminate the small molecule. Balance or not, they don't really bother lah. They don't really bother. Okay. Okay, so I guess that is all for my talks today. I hope that you enjoy it. Good luck for your semester 3 chemistry on Monday. I'll post that. If I post a little bit late, don't teacher, why so late? Why so late? Sometimes Mr. Chu also busy also. Don't think that Mr. Chu got nothing to do. Okay. So hopefully you all do the best, and then I wish you all the best in the future. Anytime, anywhere, see me, say hi lah. Okay. Okay, thank you very much. See you all next time.